Okay, so welcome back. So we are meeting after almost 2 weeks. So I hope you remember what we did last time. So what we did, we studied the topics reflection and refraction from a plane wave at a media interface, right? So if you have forgotten, which may be the case for most of you, so if this was the z-axis, this was taken as x, this was y. So this was our interface. So we had made electromagnetic wave incident, right, like this, right? So then we said we have two types of polarizations: perpendicular polarization and parallel polarization. For perpendicular polarization, E vector is perpendicular to plane of incidence, and for parallel polarization, E vector is parallel to the plane of incidence. So if we are considering perpendicular polarization, we get, since it is incident, we say EI vector is incident in this way and wave is traveling like this. So we take, to find H vector, we take, this is the direction of wave travel. So E to H, curved fingers give the direction of E to H. So E is like this. So H should be here. And we know E and H are parallel. So HI vector should be like this. Right? So then we said if both are dielectric, some part of the wave will be reflected, some part will be transmitted. So then again we calculated, since it is perpendicular polarization, ER vector will be like this, R indicating reflected. So this gives from E to H, so this should be HR vector. Similarly, obviously ET vector should be like this, then HT vector will come like this, again using right hand rule. Right? So this was perpendicular polarization. Then we use deflection coefficient is ER upon EI. We proved that it is eta 2 cos theta I minus eta 1 cos theta t upon eta 2 cos theta I plus eta 1 cos theta t. And then we proved gamma is 1 plus tau, where tau is et upon ei. So it was same coefficient and this was 2 eta 2 cos theta I. So similarly we did the same procedure for parallel polarization, right? And we got the gamma and tau relations, right? So this was what? Oblique incidence. So this was incident at an angle theta I, right? So if it is normal incident, what we said, so if this is like this, it should be, sorry, this is not the angle, this is the angle, this is theta I. So if this is normally incidence, it gives the feeling that normal gives the feeling that theta I is 90 degree, but actually if you see here, theta I comes out to be 0 degree. So if you substitute theta I, so obviously theta t will also be 0 degree. So we saw that. So this goes to 1, this goes to 1, this goes to 1, this goes to 1. So what we get, gamma as eta 2 minus eta 1 upon eta 2 plus eta 1. Similarly tau में क्या हो जाएगा, this will be 1. So 2 eta 2 upon eta 1 plus eta 2. So this is what we saw last time. So this is just a recapitulation of what we did yesterday, right? So next is numericals based on this. So 99% of the cases you will get this question, either numerical or this derivation which you did last time, right? Not 99%, I'll say 90%. I'll say not even 99%, but 99.99% will either get a question derived boundary conditions or numerical first. Second, you will get pointing theorem, usually no numericals. Third, you will get this reflection question or numerical. So out of these three, usually 2 questions are seen and each is of 10 marks. So from these 3 topics itself we can score 20 marks. So make sure you don't keep these 3 topics in options. Okay, so let's proceed to numericals. The pens, which was the new one. Okay, we'll see. So in free space, z less than 0, a plane wave with, so first thing you see z less than 0 and z greater than 0 here. So in the exam, first you should check this is a boundary condition problem or a reflection problem. So since HI vector is given here, obviously it is refraction problem. So in free space, z less than 0, a plane wave with HI vector equal to 10 cos of 10 raised to 8t minus beta z x cap milliampere per meter is incident normally on a lossless medium. Epsilon is 2 epsilon 0, mu is 8 epsilon 0, means epsilon r is 2, mu r is 1. and here mu r is 8, sorry, and here it is free space, means epsilon r and mu r both are 1, and it is incident normally in the region on the lossless medium in the region z greater than 0. Determine hr, er, ht, et, and they have mentioned specifically that they are vectors, so we have to find the vector form. So first thing, we will draw the coordinate system, obviously. So from that coordinate system we'll get the direction. So again, let's assume this as z, so this will be what, x, right-handed coordinate system, so this will be y, right? And z less than 0 and z greater than 0 means z equal to 0 is the interface, so this is z equal to 0, so this should be my interface. So where is z less than 0? Obviously here, so this is z greater than 0. So what is this? Mu r equal to 1 equal to epsilon r. Why? Because free space z less than 0 is free space, and here mu r is 8, epsilon r is 2. It is given in the question here, right? Next, what else is given? They have given hi vector. Now we have to check it is perpendicular polarization or parallel polarization. So how to check that? So hi vector only they have given. So hi vector is oriented in which direction? X cap. So it is going like this. So this is my hi vector orientation, right? And how is it traveling? In which direction? This is cos of omega t minus beta z. So since it is minus beta z, we say it is traveling in plus z direction. So it is traveling in this direction, right? So we have to find E vector. So we saw here using right hand rule, right? Like this, E to H, and direction thumb gives direction of wave travel. So thumb is pointing exactly towards right. So direction of travel is like this. So H we have here. Usually we have E first. So H is like this. So E should come from below because the E to H we have, right? So means E is coming from downwards. We know E and H are perpendicular. So E is going inside the paper. I hope you understood it. If not, you just rewind the video. So it is what? EI vector. So it is going inside the paper, right? Means it is a, so what we have considered in our derivations, that we gave a dot, that it is coming out of the paper, but it can go inside the paper also. So in any ways it is perpendicular to the plane of incidence. So what we have derived is, it is a case of perpendicular polarization. So we have to draw this diagram. Below that you have to write. From the figure we see that the given question is a case of perpendicular polarization. So now what will happen? Then check whether it is dielectric or dielectric interface. Okay. So they have not mentioned anything about sigma. So we assume it to be dielectric. Okay. So since it is dielectric interface, some part will be transmitted, some part will be reflected. So it is incident like this. So obviously it will get reflected, and since it is incident normally, I have shown normal incidence, right? So it will get exactly reflected, right? So and since it is perpendicular polarization, EI, which becomes ER now, it will again go inside the paper only. That is assumed. That is practical, in fact, not assumed also. So now direction of thumb is towards left, E is going downwards. So curled fingers, my curled fingers points downwards. So HR vector is like this, right? So from this we get the directions. And how is it transmitted? So here it will be transmitted like this only, right? So what will be my ET vector will again be like this, right? So these both are same direction. So obviously HT vector will be like this, right? So I hope you got this diagram. So just rewind and see if you have not understood. It is quite simple if you think conceptually. Don't buy it again. So then what do we have to do? So first thing is we can find beta. So what is beta? It is omega root mu epsilon. So mu and epsilon are different for different mediums. So we'll have beta 1. So let's say this is M1 and this is M2. So beta 1 will be what? Omega is given, cos of omega t, right? So 10 raised to 8 into, so it is free space. So 4 pi into 10 raised to minus 7 into 8.85 into 10 raised to minus 12. So it is beta 1 is 0.3335 radians per meter. So what is beta 2? It will be same thing multiplied by into 2 into 4, because it is into 2 epsilon 0 into 8 epsilon 0. So we have already multiplied by mu 0 and epsilon 0. So into 2 into 8. So it is 1.3339 radians per meter. Right? So next, what we need to find is HT, ET, HR, ER. So you should go logically. I should have done this later. So how you have to think, that I'll tell you. So HI दिया है, HI is given, right? So what is the relation between HI and EI? What is it? It is eta is given by E by H. Strictly speaking, magnitude of E vector by H vector, right? So if I am in medium 1, so what it will be? If I am talking about eta I incident, so it will be EI by HI. Similarly, eta R will be what? ER upon HR, and eta T will be there. So what it will be? ET upon HT. So this relation we have. And which will be medium 1? Incident and reflected, if you see the diagram, they are in medium 1. So they are in medium 1. And this has to be in medium 2 because it is transmitted. So medium 2. Right? What else we know? So if you know HI, and if you HI is given, you know eta I. What is the other relation for eta I? It is root mu by epsilon. Mu is mu 0 mu r, epsilon is epsilon 0 epsilon r. So you can find EI, right? But you don't know HR. You can find eta r. Again, you will use the same relation. But HR is not known, means we require some formulas more. So what are the other formulas? And we are using normal incidence. So we know gamma is ER upon EI, and tau is ET upon EI. Okay. So from this we can find. So now what we have got? So we can find EI, right? So let's see how to solve this now. So first what we'll find, so what they require, HR, ER and HT, ET, right? So first find eta I equal to eta R equal to eta 1. It is what? Square root of mu by epsilon. So it is nothing but free space, right? So it is 377 ohms. So if you want, you can write in terms of pi. So 120 pi ohms. So similarly, eta T equal to eta 2. It will be 120 pi into root mu r by epsilon r. So what is mu r by epsilon r for medium 2? Mu r is 8, epsilon r is 2. So 120 pi into root mu r is 8. So 8 by 2. So 240 pi ohms is the unit, right? Fine. So next what we can use? We know HI, we know eta I. So we can find EI. So EI is what? Eta I into HI. So EI equal to eta I into HI. But remember, I have not written vector, so it indicates it is magnitude. So what is magnitude of HI vector? 10. And eta I is 120 pi. So 120 pi into 10. So therefore EI equal to 1200 pi. Right? But what will be the unit? Remember, it is milli. It is milli here. So this should also be millivolts per meter. Be very careful. So but I want EI vector. Right? So what will be EI vector? So from this you will get the direction. How is EI vector? It is going into the paper. So if you see, this is Z, this is X. Even though Y is looking like this, you have to think in 3D. So it will be perpendicular to X and Y. So it is coming towards you or out of the camera. So it is what? Plus Y for coming towards you. But this is a going into symbol. So it is minus AY cap. Right? So EI vector is 1200 pi. So this will be as it is, cos of 10 raised to 8 t. So cos of 10 raised to 8 t beta. So beta is what? We are in which medium? Medium 1. So beta is 0.3335. So 0.3335 Z. And we got it as AY cap millivolts per meter. And what is it going into? So it is in negative Y direction. So minus. So that we have to include on our own accord. So it will not come from mathematics. Okay. But now the question is, will this be minus or plus? That also you have to check. So this is quite a detailed problem. So you see when it is incident, it is going like this, right? So we are going in positive z only, right? So this has to be minus only. Why am I saying this is because when it is reflected, it is traveling in minus z direction. So for reflected, it will be plus. Okay, that is the reason I am telling you this. Okay, so then we got EI, right? So we can use gamma is ER upon EI. Can we use? No, we don't have ER yet. We don't know gamma also. So what is the other formula? So this is the way you have to think. I have not biated this. I am going in a flow. So gamma is eta 2 minus eta 1 upon eta 2 plus eta 1. And what is tau? We know it is 1 plus gamma. Right? So therefore gamma you can calculate. So 240 pi minus 120 pi. It is 120 pi only. Divided by addition of this 360 pi. So it is 1 by 3. So tau will be 4 by 3. Simple. No need of calci. Right? So now you have gamma, you have EI. So you can find ER. Right? So therefore ER vector will be what? So minus EI. So EI into gamma means just multiply this by plus 1 by 3. So we'll get minus 400 pi cos of 110 raised to 80 minus 0.3335 Z. AY cap, that doesn't change, millivolts per meter, right? But now what is happening? It is reflected wave, so you have to see that it is in traveling in minus z direction. So you will make this as plus. Okay, so this is your answer for ER vector. Fine. So next what we have to find? So we are done only with ER vector so far from what is asked. So what will be HR, HT and ET we have to find out. So we are done with this. So what we have so far, let's see. So we have tau, we have EI, so we can find ET now, right? So from ET we can get HT because eta is E by H also. So this is the way you have to think. Okay, so where was I? What was I said? So tau is ET upon EI. We know tau, we know EI. So ET is tau into EI. So I can use vector here, which is equal to, so therefore ET vector equal to, so what is it? Tau is 4 by 3 into EI vector. So this answer is just multiplied by 4 by 3. So 4 by 3 into 1200. So 4 divided by 3 into 1200. Am I correct? Sorry. 4 divided by 3 into 1200 pi. So 1600 pi. So what do we get? 1600. Have I taken the pi? I forgot again. Sorry. So 4 divided by 3 into 1200 pi. Sorry. 1200. Oops. 1200 pi. So 1600 pi. And minus sign. So minus 1600 pi cos of 10 raised to 8t minus 0.33. This is what beta 1, but now we are in transmitted wave, right? So what will be the beta? Beta will be beta 2. So you have to be very careful. So it will be 1.339. So 1.3339 Z. And what is the direction? AY cap millivolts per meter. Okay. So we are getting the same direction, right? Minus AY cap. Right? So what we are done with ET. So let me just take what we are done with ET. We are done. ER we are done. So HT and HR is remaining. So once you have ET and ER, so what you use just eta is E by H, right? Because you know eta, you know E, so you can find H. So H is what? E by eta. So first go for HR. So H is E by eta. So we are in reflected. So it is medium 1. So therefore we can find HR vector. So just divide ER vector by eta 1, which is 377. What is eta 1? 125. Right? So ER vector. So ER vector is here. So divide by 125. So 400 pi. So means 400 divided by 120. So 10 by 3. So HR vector is 10 by 3. Pi has got cancelled. Yeah. So cos of 10 raised to 8t, and it is reflected, right? So same thing you can use. So cos of 10 raised to 8t plus 0.3335 z a y cap milliamperes per meter, right? So reflected. So this will be plus because we are in minus z direction, and this will be medium 1. So we are correct, right? Similarly, what will be ht? It is et upon eta 2, right? So therefore, what will be ht vector? Et vector. What is et vector? We have it. So this is et vector. So upon eta 2 means 1600 divided by eta 2. So what was it? 245. So divided by 240. So 20 by 3. So 20 by 3 cos of, we'll see about the minus sign later, 10 raised to 8t, and we are in medium 2. So it is traveling in plus z only. So minus 1.3339 z. In which direction we are now? ht vector. So you cannot take ay cap. So see the diagram for that. So ht is in which direction? Plus ax cap, right? So you don't have to take the minus sign. You have to take the plus sign and ax cap. And it is milliampere per meter. Okay. So this is the way you have to solve. So I hope if I got all the 4 quantities. Yes, HR and HT we just found out, right? So again, I'll tell you. So you might have said, so you use the formula only to get the signs here. So if you check HR vector plus ay cap. So let's see whether I have done correctly. No, HR is going in minus ax cap. So this also we should change. So this is minus and this is ax cap. Remember, you will only get the magnitude of this. You will only get the magnitudes, right? HR is ER upon eta 1. It is not talking about direction. So just take the magnitude, and for the positive or negative sign, and for the unit vector direction, see the diagram. Okay. So I'll write it, because usually students, when they see something their teacher is writing, they remember it. So for magnitude, use eta is E by H or eta equal to mu by epsilon. For directions, that is vector and polarity. So plus and minus sign I am calling polarity. Use diagram. So that diagram which you draw should be correct. That is the assumption. Okay. This is the sum. Strictly speaking, it is very simple. You just have to think one notch higher. So it is not complicated. And once you are clear about the concepts, it is not a big deal. Okay. And it comes in the exam for 10 marks. So it is worth it. So let's proceed further. So again, normal incidence is there. For normal incidence, determine the amplitudes of reflected and transmitted ET vector and HT vector at the interface of two regions, Z equal to 0. Okay. This cannot be vectors because they have not given vectors, right? So we cannot find the vectors. We can find the magnitude only. So you might say, sir, vectors are not given. How to solve this? In fact, it is simple, right? If vectors are not given, they have just given magnitude. So you don't have to think about the directions and polarities. You just have to use those. Eta is E by H. Eta is E by H you use. Then you use eta equal to mu by epsilon. Then what you have to is gamma is eta 2 minus eta 1 upon eta 2 plus eta 1. and tau is 2 eta 2 upon eta 1 plus eta 2, or tau is 1 plus gamma, depending on perpendicular or parallel polarization. So this is in fact a simpler sum, and this also comes for 10 marks or maybe 7 marks, I am not sure. Okay, so this is a homework problem for you, so you can solve it yourself. So let's proceed to the next sum. So let's see the next sum. So plane interface between two perfect dielectrics is located at z equal to 0. So again, the interface which is separating the two mediums is z equal to 0 as the previous sum. A 4 GHz uniform plane wave traveling along z axis is incident from region 1 z less than 0 onto region 2 z greater than 0. The wavelength in dielectrics are lambda 1 equal to 6 cm, lambda 2 equal to 4 cm. Both materials are non-magnetic. Means what is given, so it is becoming a lengthy problem to read, so I'll write what is given first. Lambda 1 is 6 cm sorry, lambda 2 is 4 cm, and f is given as 4 gigahertz, and mu r1 equal to mu r2 equal to what it will it be when, because they are given both materials are non-magnetic. So what percentage of energy is reflected, transmitted, and SWR? So what is SWR? Standing wave ratio, that we have not studied. We'll study in transmission lights, which is the next module. So probably we'll start with it from tomorrow. So that we'll see. So that formula only I'll give. What is the concept we'll see in the next module. So basically how much energy is reflected we have to calculate. Means how much energy is nothing but power. Means power, how much is reflected. So means we have gamma is nothing but what? Reflection coefficient. So it gives how much of the energy is reflected, right? So basically we have to find gamma, right? And since this is a reflection problem, means gamma will be what? Eta 2 minus eta 1 upon eta 1 plus eta 2. Means you have to find eta 1 and eta 2. So for eta 1 means you will require what? Eta is what? Root mu by epsilon, right? Means you will require what? Mu 0, mu epsilon 0, you know, mu r is given, so epsilon r is not given. So epsilon r is to be found out, so that is not given, so that is a problem. So what is the other formula for eta? E by h, but they have not even talked about of E and h, so this goes out of question. Means it gives a hint that we have to find epsilon r. So I'm telling you how to think, you don't have to buy at problems. Okay, so for that what they have given, let's see. So they have given lambda. So what is the formula for lambda? Lambda is Vp by f. So f is given, so means we have to find Vp. So what is Vp? What is Vp? Vp is omega by beta, right? What is Vp is omega by beta, and both are dielectrics. So what is the formula for beta? It is omega root mu epsilon. So omega gets cancelled. So what is it? 1 upon root, what is mu? Mu 0 mu r. Mu r is 1, so I will not write. Epsilon is epsilon 0 epsilon r. What is 1 by root mu 0 epsilon 0 c? So c by root epsilon r. So Vp is what? C by root epsilon r. So if you are confused, we have already proved this for a perfect dielectric. Vp is C upon root epsilon r for a dielectric. We have proved this in the phase velocity wala lecture. So you can refer to that lecture if you don't know this formula. So what will be lambda again? Lambda is Vp by f. So what will be lambda? C by root epsilon r into f. So therefore root epsilon r is C by lambda into f. So epsilon r equal to C square by lambda square f square. So everything is given. So epsilon r1 is, so C is 3 into 10 raised to 8 upon lambda. So let me take that as x because I want to calculate it 2 times. So x into f, it is 4 into 10 raised to 9, and this should be squared. So squared, but we have to calculate x, so type on calc. So what is the value of lambda 1? It is 6 centimeter, I remember. So 6 into 10 raised to minus 2. So what is it? 1.5625. So again you want to use the same thing, only x is changing. So again this, now it is 4 centimeter. If you check the question, if you are not sure. So it comes out to be 3.516 LT. So take at least 3 to 4 decimal places. Okay. So next, so we have got epsilon r1, epsilon r2. So why we require that? I forgot, because I don't buy it again. So I've got epsilon r1. So we can find eta 1, eta 2. So eta 1 is medium 1. So eta 1 is root mu 1 by epsilon 1. So root mu 0 mu r1 upon epsilon 0 epsilon r1. So therefore eta 1 equal to root mu 0 by epsilon 0 is how much? 120 pi. So 120 pi into root mu is 1, mu r1. So epsilon r1 is 1.5625. So 96 pi ohms. Similarly, eta 2 will be, this will be 3.516. Where is that pi? We have absorbed it. So 201.0512 ohms. So we can find gamma. So it is minus 96 pi divided by answer plus 96 pi. Yeah. So it is, we have done some mistake, because gamma should be less than 1. So let me check. So 96 into 3.1410 is 301 eta 2 minus eta 1. Yeah, I have done some mistake in here. So I'll write this as 301.593. Okay. So 201.0512 minus 301.593 upon 201.0512 plus 301.593. Yeah, 0.2. So take the magnitude only, because gamma cannot be negative. So it is 0.2. Right? So if you calculate in percentage, so you write therefore percentage of power reflected equal to 0.2 into 100. So how much? 20%. So what will be transmitted? 100 minus this. So obviously 80%. Right? We have got these first two answers. So SWR. So SWR formula is 1 plus mod gamma upon 1 minus mod gamma. So gamma is minus 0.2. So mod gamma is 0.2. So 1.2 divided by 1 minus 0.2. Am I correct? Yes. So 3 by 2. So standing wave ratio equal to, it is denoted by rho, by the way. So it is 1.5. Okay. So again, this sum was asked in the last to last exam for 10 marks. And no one solved it. That also I'll tell you. Because no one thought about it in this way. So you have to think when you have numericals. Okay. Think in this way. Okay. So don't try to buy it or just write what is given, etc. First write what is given, then think about the concept, think about what is given and what has to be found out. From that you try to create a flow. So from that you will come to the conclusion how you have to solve. Okay.